Hello, everyone. Good morning, afternoon, and evening. Dear authors and invited guests, welcome to Technical Session 13D. I'm Pranjal Bange, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic, it is my great pleasure to welcome you to the 11th International Congress on Information and Communication Technology, ICICT 2026 in London, UK. The 11th edition of the conference is being organized in a hybrid mode. The physical event was held on 24th Feb in London, UK, and the virtual event is being held through Zoom from 25th to 27th February 2026. I hope you'll enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 6 presentations. Each presenter will be given 12 minutes for the presentations and 3 minutes for questions and answers. In 10 minutes, I'll raise a gentle reminder. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any queries or updates, then you can write it to me or to my co host in the chat box. Now, before we start the session, I would like to introduce you all to the session chair of this session, Dr. Suvarna Patil. She's an associate professor at DY Patil International University in Pune, India. She brings 18 years of teaching experience and specializes in networking and Internet of Things. She's committed to academic excellence, impactful research, and fostering innovation in emerging communication technologies. Ma'am, would you like to say a few words?
Good, mo- um, Good evening, all. So, thank you, organizing team of ICI for giving me this opportunity. So, I would like to say all the best to all the participants. So, please do follow all the rules mentioned by Madam Pranjal ma'am. So, thank you.
Thank you, ma'am. Next, I would like to introduce our next session chair, Fernando Latorre Lopez. He is the Chief Technology Officer and co-founder of Conconectate Soluciones y Aplicaciones at SL. His technological expertise spans blockchain, cybersecurity, and digital health, where he focuses on developing secure, innovative, and scalable technology solutions. Through his leadership, he contributes to advancing digital transformation and applied technology in industry focused environments. Sir, would you like to say a few words before we start?
Yes, thank you. It's a pleasure to chair this panel and to welcome such diverse and thought-provoking contributions. And basically, presenting research is never a trivial task. It takes courage to expose your work, your ideas, and sometimes even unfinished thoughts to an academic audience. So I would like to say something to all the speakers before we begin. Please feel comfortable. If you miss a slide, if you lose a word, if something does not come out exactly as planned, don't worry, just continue. Yesterday, for example, I was presenting and I skipped one of my own slides without noticing, so it's happened to all of us. What truly matters is the substance of your contribution and the discussion it generates. I look forward to the insights and discussion, and let us begin.
Yes. Thank you so much, sir. Now we'll start with the presentations. I would like to apologize in advance if I mispronounce your names. We'll start with the first presenter, Carlos Alfredo Silva Villafuerte. It seems so is not present. Then we'll be moving forward with our next presenter, Peguende Brigette. Unfortunately, even she is absent. Then I'll invite our next presenter, Navya Martin Kolapalli, to present her paper on developing a mental health interface ontology using social media graph clustering.
Hi,
Ma'am,
Pranjal. Thank you for the opportunity. Yeah, I'm right here, but my research student Sarah will be presenting the paper.
are they present, ma'am?
Yeah, Sarah is right there.
Hello.
Hello, you may start by presenting your paper and sharing your screen.
Hi, yes. Are you all able to see my screen at the moment?
Yes, Sarah, we can see the stage.
Okay, perfect. Let me just start. Hello, everybody. Will the time be starting now?
Yeah, you can start.
Okay. Hello, everybody. My name is Sarah Ainani, and today I will be presenting my research project titled Developing a Mental Health Interface Ontology using Social Media Graph Clustering. I am a computer science researcher focused on natural language processing and knowledge representation. This project explores how we can fully and formally represent informal mental health language used on social media platforms, and I will begin by outlining the structure of this project. As we can go on and continue, first off, I want to start off with what an ontology is. An ontology is a formal representation of knowledge within a specific domain, and it defines concepts and establishes relationships between those concepts. Ontologies include structures that organize knowledge logically. They define object properties and data properties that describe relationships and certain attributes. These structures allow machines to interpret the meaning rather than simply match specific keywords. And ontologies are widely used in healthcare to standardize this specific terminology. So diagnostic systems rely on ontology-based identifiers to maintain this consistency. Without the ontology structure itself, the language remains ambiguous for most computer systems. Now that we fully understand what an ontology is, we can really examine how human grammar, like synonyms, are handled within these specific systems. Now, the problem with synonyms itself, in structured ontologies, multiple expressions are mapped to a single concept identifier. For example, fever and pyrexia were both referring to the same medical condition. This prevents fragmentation in medical databases. It ensures variation in wording, does not create separate entries or entities. This system works effectively in standardizing clinical environments, and people use slang, metaphors, exaggerations, humor to describe distress. These expressions often don't correspond to existing clinical concepts. As a result, informal mental health language remains unstructured, bridging an informal expression motivation gap. First, I want to look at the ontology development lifecycle. As you can see here, this is developed by Natalia F. Noyes framework. It begins with defining the purpose. The next is domain knowledge is really gathered from research articles and databases, which concepts are identified and organized into different structures. And ISA relationships define a specific subclass. Object and data properties are used to define specific relationships and specific attributes, as well as Prisma guidelines were used to support systematic data selection. Next, I'd like to move on to the motivation. Digital mental health tools have expanded recently over the years, and many of these systems relied on natural language processing to detect distress and certain mental health related issues. However, existing ontologies were created primarily for structured medical environments. They often fail to capture casual emotional phrasing. For example, I feel burnt out or I'm mentally cooked don't really match formal clinical terms. So these expressions describe real psychological experiences, and when systems fail to recognize such language, distress signals may be missed. So once again, creating a gap between lived experiences and structured clinical representation. And an interface ontology can translate formal language into their structured meanings. So we're going to start off with the methodology. We've broken it down to 7 stages to fully get our results. I'd like to start off with stage 1, which is the dataset curation. First, we selected certain subreddits in certain emotional expressions during mental distress. These included r/depression, r/anxiety, r/suicide watch. Now, using Octoparse to scrape these websites, we collected 16,000 publicly available posts that are linkable. You're able to click through them. And these posts reflect spontaneous, informal communication, and they differ significantly from structured clinical documentation. So the dataset captures real-world mental health discourse and as well as personal emotional narratives. And this stage was created for raw material analysis. Well, the next step was kind of for pre-processing, which I will now move on to. For the pre-processing, we initially avoided normalization techniques such as stemming or lemmatization, trying to avoid the lack of context. And for example, burnout vibes or burn vibes are two completely different things and they erase the meaning. So we would need to preserve the slang and the original phrasing as well. The tokenization was applied while maintaining expressive structure while emotional tone was prioritized through the processing. But preserving the phrasing supports accurate embedding into the ontology itself. So our approach emphasized context over the simplification itself. Now that I mentioned embeddings, I wanted to move on to the embeddings itself. We used a multi-mental Roberta model, and using dense vector representation, this model was fine-tuned for mental health discourse. These embeddings capture meaning, emotional tones of words and phrases. Contextual embeddings consider surrounding words, sentence structure, and using the cosine similarity measures that we used between each vector, each keyword was able to be detected computationally. Unlike keywords matching, embeddings create a deeper meaning. And this stage kind of prepares us for to be able to graph, which I would like to move on to the Louvain community detection. This was important for building a similarity graph, and each node is representative of a Reddit post. Edges were weighed using cosine similarity, same with the embeddings, and applying the Louvain algorithm to detect certain communities. It is able to identify densely connected clusters without having them overlap. It does not require specific predefined categories, but follows the context relevance, and each psychological theme emerges naturally. So clusters reflected experiences such as burnout, rumination, and interpersonal conflict, and these clusters form the basis of concept extraction itself. For really quick reference, the curated concept list from the clusters we extracted approximately 2,700 candidate expressions, and the term frequency or the inverse cluster frequency was weighted within these communities against each other, and both conventional and internet like native terms were used within the study and was able to help us construct the ontology itself. Now, for the ontology construction, the mental health interface ontology was structured as a hybrid interface ontology. The ontology includes 369 concepts. It contains 1,095 logical axioms. There are 24 object properties and 17 data properties. The concepts are organized into processes, qualities, and dispositions. The logical structure supports that we have this interference, this backup and this reference, as well as reasoning. And the final step was to kind of map out these concepts to a specific clinical ontology that we were working on. And for the ontology mapping, each phrase was mapped to clinical parent concepts if possible. We used exact match, close match, as well as related match. Close matches indicate strong similarities without needing the full relevance. For example, I'm running on fumes maps to the cluster of mental fatigue. So matching the interoperability with the SON med and the mesh systems, the transformer model as well turns the slang into structured clinical knowledge. Next, I would like to move on to the architecture diagram slide. On this slide, pictured from left to right, it starts with collecting the data itself from Reddit, and the contextual embeddings convert text into vector representations. These vectors form kind of a similarity graph, and Louvain clusters identify coherent neighboring clustering communities. And these concepts, extractions, transform clusters into candidate ontology terms themselves. As a result of this study, One cluster representing exhaustion included phrases such as burnout vibes, mentally cooked, running on fumes. This demonstrates a successful grouping and successful clustering within the context of relevance and how they might relate to each other. After curation and validation, 369 expressions were formalized into structured ontology concepts, and the ontology is supported by 1,095 logical axioms, as I've mentioned before. And the mental health interface ontology uses internet native language as well as successfully use structured ontologies to create this result. The methodology itself integrates NLP, graph theories, and ontology engineering into a producible pipeline, and the result shows that social media discourse can inform formal knowledge modeling without losing a clinical or formal need to have semantic nuance or speaking to users or speaking to staff necessarily. So overall, a mental health interface ontology serves as some sort of semantic bridge connecting lived experiences to machine readable healthcare systems. And I would like to also show you the results or the Louvain method graph itself. As you can see, the pink clusters, the color was purely for organization, and each is stuck together in their relevance. Thank you, everybody. If there is time for any questions, please let me know. If you have any questions, I will be happy to answer them.
Hello.
Hello.
Yes. Can you go to your last slide?
Yes, I can. This one?
Okay, yes. So as you have explained this, but can you explain in detail, means how you are interpreting these clusters?
So with these clusters, using the Roberta model as well as human interference, like human analyzation, we're able to tweak the Louvain model and the data set. With the clusters, we use filters as well to kind of focus on the relevance between each other. We didn't want we didn't want nodes in the same cluster if they mentioned a similar word, but they didn't share the same context. So we stick to the Roberta model, tested it out multiple times, and then went back with human eyes.
So while formation means while cluster formation, can you explain means for cluster formation, which parameters or which characteristics or which features have you considered?
The features that we mostly stuck with is the medical base that the
But
DSM.
can you name list something? Some
Like depression, anxiety,
okay.
certain disorders that would be classified but aren't picked up by certain systems.
And which evaluation parameters you have considered to evaluate the performance of your model?
If they're using similar slang terms, we ourselves define the slang terms themselves if they needed the help, the Roberta model itself.
Which basis you have concluded? Have you concluded that your model is performing best?
Excuse me, say that again. I'm sorry, you cut off.
Okay. Based on which evaluation parameter you are concluding that your model is performing better than
We're
the other
concluding that
model?
we're concluding from our Louvain and Roberta model. And after that, we run those two models. We went back with human relevance and we proceeded to be accurate, but as well as strictly we stayed on the Roberta model and staying on that model specifically. We tried a couple models before, but that worked the best for us as parameters, as defining or placing them in specific clusters.
Okay. It's done from my side. Thank you.
So, do you have any questions for her? Fernando, sir, do you have any questions for her?
Yeah, my only question is, how do you think you could implement this solution in the real world? What kinds of organization or entities could benefit from this solution?
My goal on making starting this project, I would like to kind of market this towards mental health facilities, those who work with young teens, those who work with people through telehealth as well, who might not be able to have a updated or certain kind of ontology that because every 10 years slang terms, every 5 years slang terms might change as well. And if we're able to automate the model and have the octoparse parse scrape or build a scraper tool to have the tool scrape websites by itself and bring back that data, hopefully we can get it to work with mental health professionals to have it help with the general public.
Perfect, thank you.
Thank you.
Thank you so much, Sarah, for that interesting and engaging presentation.
Thank you.
Next, I would like to call upon our next presentator, Noorjahan Mithila. She would present her paper on Dual PathNet, a stacked ensemble framework for multi-class prediction of diabetes, heart disease, and their comorbidity. You may share your paper by presenting your screen.
Yeah, sure. I hope both of you saw my screen.
Yes, Noorja, we can see your screen.
So my name is Nurjan Mithila. I'm from Department of CSE from Bangladesh University of Business and Technology, Dhaka, Bangladesh. Today, I would like to present our research titled Dual PathNet and Ensemble Stacking Framework for Multi-Class Prediction of Diabetes, Heart Disease, and their Comorbidity. Diabetes and heart disease are two major clinical diseases in the world. Those diseases affect millions of people, increase healthcare costs, causes serious complications. Very often, a patient with diabetes also develop heart disease. When both diseases occur together, the risks become much higher. But most existing machine learning models predict only diabetes or only heart disease. They do not predict both together. So with both, we thought, why not create one model that predict all possibles? Most of the state-of-the-art previous research mainly focused on binary diabetes prediction, binary heart disease prediction, and then separate modeling. Most studies use stacking, but they work on small clinical dataset. They did not focus on large population survey data. They did not build a four-class problem. Also, many works did not properly handle class imbalance. So there was a gap in unified multi-class multimorbidity prediction. The main problems are diabetes and heart disease often happen together. Most systems treat them separately. Binary models ignore disease interaction. Class imbalance make a comorbid prediction difficult. So we need one integrated multi-class framework. Our goals were build a four-class prediction model, handle class imbalance, select most important feature, develop a strong stack ensemble model, improve accuracy and generalization. Now, I would like to explain our methodology in details. We use two large-scale dataset, BFRSS, Behavioral Risk Factor Survey System 2015 dataset. BFRS is a large public health survey dataset. First dataset, diabetes dataset, it is a health indicator dataset. It almost 253,000 records. And second dataset were heart disease indicator. It has almost 290,000 records. Those dataset include age, BMI, smoking, blood pressure, cholesterol, physical activity, and general health. Then we perform merging. We select common feature, standardized variable names, cleaning the inconsistencies, and merge both dataset. Merged dataset was around 5 lakh plus representations. In the pre-processing step, we apply data cleaning, remove missing values, standardize features, and perform one-hot encoding to convert categorical data into numerical format. And then we create 4 classes, which is the core part of our work. Core part of our work 0 for, then we create 0, 1, 2, and 3. 0 for no disease, 1 for diabetes only, 2 for heart only, and 3 for both diseases. In real world, most people are unhealthy, very few are both diseases. If we train directly, model will mostly predict no diseases. So we apply bootstrap oversampling. Bootstrap oversampling increase minority class samples, apply only on training data, balance all classes. After oversampling, class distribution become balanced. This improve minority detection. Instead of using all feature, we use a two-step feature selection process. First step, mutual information. Measure how strongly each feature is related to the target. Rank all the features. Then recursive feature elimination, RFE. Remove less important features step by step. After that, we select top 20 features. Those important features include age, BMI, smoking, blood pressure, cholesterol, physical activity. This step improve performance and reduce noise. Then we split data into train, test, and validation. 70% for train, 50% for test, and 50% for validation. We use satisfied scripting. We also use 5-fold cross validation and macro AUC. Macro AUC ensure balanced performance across all the classes. Then model selection, we tested different models, linear, boosting, and tree-based. Linear models, logistic regression, random forest, XGB, boost, light GBM, and cat boost. We observed tree-based model perform better because health data are complex on non-linear relationship. Stacking ensemble and meta model. Then the main part of our dual path network paper is we build a stack ensemble model. Base learner base models make predictions. Those prediction probability become new inputs and a final model learn from those prediction. Final output is generated. We choose CatBoost as a meta learner because CatBoost is strong for tabular data, handle categorical features well, reduce overfitting, and this combined architecture is called our dual path net. And then we evaluate some results by accuracy, precision, recall, F1 score. Here is our results part. Here we see two figure after oversampling and before oversampling. Before oversampling, our class balance were too poor. Then we use oversampling, bootstrap oversampling around 1,50,000 for both classes. That's why our class was balanced. And here is our correlations of our features. We choose 10 models, linear boostings, and those models perform by their accuracy. We choose which base models, 3 models, 3 base models, and their accuracy, precision calls, and F1 scores are there. And the final meta model as cat boost, cat confusion matrix that shows our 4 class was balanced perfectly. Then our test case, test accuracy, macro AUC result, and 5-fold cross validation accuracy was provided. Then our key contributions are we contributed uniform 4 class modeling, structure feature selection, proper imbalance handling, high performance stacking architecture. In conclusion, dual path net predict diabetes and heart disease together, handle class imbalance, use smart feature selection, achieve high accuracy, shows strong generalization. It can support prevention, healthcare analysis. Thank you. Those all from me. If you have any question, you may ask.
Can you go to your result slide?
Sure.
So, can you explain this before oversampling and after oversampling? As Miss, what was the effect of it? Actual.
Okay, sure. Before oversampling, when we merge the data set and create four classes, the class 0 for no disease is become majority class, and class 3, which was both disease, it was the minority class. If we train those data set, our model become biased to both diseases. So we can use oversampling. The minority class was a priority in this case, and we oversampling both class around 1,50,000 for both classes. That's which improve our results.
Okay. So as you said, both classes. So I am able to see here the four different classes.
Yes.
So for four different classes, it is.
Yes.
Okay. Actually, and which model have different models you have compared?
Here I use tree-based model, extra tree, random forest, decision tree, cat boost, XGBoost, LightGM, logistic regression, breeze, ADBA boost, and perceptron.
So extra trees, can you explain in short?
Extra trees, it is a tree-based model. It performed well because our data is non-linear. Medical healthcare data are non-linear. They work perform on tree base can predict other models can work perform one linear models, but a tree-based models, they can make trees like BMI is greater than 15 or others. They use the prediction like the model was trained those model those
Okay.
features.
Okay, yes, that's fine. Okay, thank you. Done from.
Thank you.
Sir, do you have any questions for her?
Yeah, I would like to ask what will be the next step, in your opinion, to bring it to the market? What kinds of partners or solutions will benefit for that, in your opinion?
Sorry, I can hear your question.
Yeah,
Can you
is
repeat?
what, in your opinion, what will be the next steps to integrate this your solution, your knowledge with in the real world?
So it is a support in the medical session that healthcare analysis that predicted both heart disease and diabetes together. And if we class balancing that handles our class balance and smart feature selection, it causes the high accuracy and shown strong generalization. It helps our medical session instead of a doctor.
Okay, thank you.
Welcome.
Thank you so much, Nurjaha, for that wonderful and interesting presentation.
Welcome.
Yes. Next, I would just a moment, guys. Next, I would like to call upon next presenter, Bashair Farid Al-Tulaihe, to present his paper on green ICT adoption in Saudi Arabian and Australian universities. You may present your paper by sharing your screen.
Can you see the screen now?
Yes, we can see the screen.
Hello, everyone. Thank you for joining. My name is Bashair Al-Tulehi, a lecturer at King Faisal University. And today I present our vision paper titled Green ICT Adoption in Saudi Arabian and Australian Universities. In this presentation, I will discuss why green ICT adoption in universities is not only a technical issue, but also a behavioral and a cultural one, and why it requires a culture-aware socio-technical pathway. So when we examine the relationship between ICT and environmental sustainability, we face a paradox. On the one hand, ICT can support environmental sustainability. On the other hand, ICT consumes energy, e-waste, natural resources such as fresh water and rare metals, especially with the increasing use of generative AI. So environmental outcomes depend on how ICT is governed and designed. So universities play a major role in promoting environmental sustainability, not only as major ICT consumers, but also as behavioral influencers. In Saudi Arabia, for Saudi universities, research shows that there is some awareness participation gaps in green ICT adoption. Additionally, international evidence indicates limited student awareness of Gen AI's environmental impact. In the Saudi context, Gen AI or generative AI environmental awareness remains underexplored. In this vision paper, we adopt a comparative perspective between Saudi Arabian and Australian universities. For Saudi Arabian universities, they are undergoing rapid digital transformation in line with Saudi Vision 2030, which emphasizes digital transformation and environmental sustainability. However, the institutional integration of green ICT adoption or green ICT practices and strategies remains emerging in Saudi universities. In contrast, for Australian universities, they demonstrate more established green ICT governance structures and practices. So comparing these two different contexts enables or can enable the identification of any transferable lessons, also as well as any cultural or behavioral aspects influencing green ICT adoption. This slide presents findings from a study conducted on 44 universities in Saudi Arabia, and it shows the levels of sustainability integration in Saudi universities. So about 72% of these universities mention sustainability in their vision statements, but only 45.5% actually included in their strategic plans, and none had dedicated campus sustainability plans. Other studies also reinforce this gap. This study shows the level of sustainability awareness and implementation in Saudi universities at the faculty level and the student level. So faculty demonstrated high awareness of sustainability issues, but modest participation in sustainability-related activities, and also limited involvement in sustainability decision-making. While students showed low levels of sustainability knowledge, basic sustainability concepts such as recycling and energy conservation, also minimal participation in green ICT activities. Okay, so now green ICT is not only purely technical. There is also a cultural and behavioral dimension. Research in Saudi Arabia indicates that cultural, social, and religious values shape attitudes toward technology adoption. Also, the cultural norms influence the requirements engineering process, including communication and the stakeholder negotiation. Also, another international empirical evidence suggests that ICT visibility mechanisms can influence digital behavior. So when you make ICT consumption visible to users, it can influence their digital behavior. However, the integration of cultural factors into environmental sustainability-oriented requirements engineering in Saudi universities remains underexplored. Also, the design and evaluation of such culturally tailored ICT and Gen AI visibility tools in Saudi universities also remain underexplored. So to address these challenges, we propose a culture-aware socio-technical framework for green ICT adoption. So this framework has three interconnected dimensions. The first dimension is environmental sustainability-oriented requirements engineering. So we aim to embed the environmental goals into the system analysis and design aspect, or the requirements engineering aspect. And then the second dimension is to design culturally tailored ICT and Gen AI consumption visibility tools to make Gen AI and also ICT consumption visible to stakeholders in a meaningful and understandable way. And we have at the center of this framework, we have culture-aware processes or culture-aware design processes, because we mentioned earlier that requirements engineering is influenced by culture. So we aim to build the first dimension and the second dimension based on cultural aspects or cultural values, because they are influenced by culture. And together, this framework connects user behavior, system design, and cultural aspects. So in conclusion, environmental digital sustainability challenges are inherently socio-technical, cultural, and behavioral factors shape ICT sustainability adoption. And we propose a culture-aware socio-technical pathway to integrate the three dimensions. And the aim is to strengthen environmental digital sustainability in universities. Thank you for your attention, and I welcome any questions and discussion. Thank you.
So, ma'am, do you have any questions for her?
Yes. Can you go to that slides, the sustainability and that you mentioned diagram?
Yeah, sure. The framework?
Framework. So. Also, because as you are saying, this is the sustainable environment and green ICT. So actually, it is going to affect the energy parameter also. So you should focus, I think. So this is just my suggestion.
Yes, sure.
Focus on that.
Yeah, you're saying that we should focus on
one more. That's energy parameter, sustainability. Along with the sustainability. Okay.
Okay. Yeah, sure.
Okay.
We'll take that
from
into
my side.
consideration.
Thank you.
Thank you so much for your feedback. Thank you. Any other questions?
Yes, I would like to ask you, if a university asks you to where to start tomorrow, what will be the first steps, the first actions to reduce the ICT environmental impact while preserving the digital innovation, in your opinion?
Okay, so the question is how to implement this. What is the first step?
How to put in practice?
Yes, the first step would be to actually evaluate the current state at these universities. So what is the current state in Saudi universities, for example? We know that there is an implementation gap. So we look at their strategies. What are they doing? Are there any established strategies? We know that there are strategies for environmental sustainability, but there is no implementation. Why there is no implementation? Because there is no awareness of the the cultural aspect, or there is no awareness of the importance of the environmental implication of a green ICT. So how can we address these solutions? It starts with investigating the current situation, the current challenges. What do they have, what they don't have, and then build on these findings. So this framework is based on what we have found based on the literature review and on the current studies. So I would say we would look at the current state at each university and then suggest solutions based on those.
Okay. Yes, I think maybe collaboration between students and universities on that group of students to propose their vision could be helpful for the universities to have a wider vision about how to start implementing some kinds of papers, online papers or something like that in the university, for example, on blogs or something like that.
Sure, I totally agree. Yes.
Thank you.
Thank you so much. Thank you.
Thank you so much
Any other questions?
for your presentation and the knowledge that you shared with us.
Thank you so much.
Further, now I'd like to call upon our next presentator, Dongming Jie, to present his paper on predicting drug relapse risk using gradient boosting models, a comparative study on multidimensional behavioral features. So you may present your screen and start with your paper.
Oh, sure. May I start now?
Sorry?
Yeah.
It's Dongming Jia. Today, I will present our work on predicting drug relapse risk, an issue of major importance for public health and rehabilitation practice. Moving beyond the conventional statistical approaches, we apply the gradient boosting model to a large-scale cohort of nearly 5,000 individuals with the aim of developing a more accurate and well-calibrated decision support system. Why is this prediction hard? Traditional methods like logistic regression assume that risk factors are additive, but human behavior isn't simple math. As shown on the right, factors like impulsivity and family support interact in complex, non-linear ways. Our motivation is simple. Linear models undertake this complexity. We need algorithms that can naturally model these high-order interactions. We utilize a robust structured dataset of 4,962 individuals. Unlike many studies that rely solely on demographics, we integrated standardized psychological scales like the Barras Impulsiveness Scale (BRS-11). The target variable is strictly defined. Any verified relapse within 12 months post-discharge. The dataset is fairly balanced with a 53% relapse rate. Methodological rigor is central to our work. We used a stratified five-fold cross-validation strategy, crucially to prevent data leakage or preprocessing steps such as imposition and one-hot encoding were fitted only on the training fold. We generated out-of-fold pool of probabilities for the entire cohort to ensure unbiased performance evaluation. Now, let's look at the discrimination performance. This ROC plot tells a clear story. The red line, XG boost, and the green line, light GVM, significantly outperform the blue line logistic regression. We achieved an AUC of 0.822 with XG boost compared to only 0.710 for the linear model. This 11% gap confirms that modeling nonlinearity is essential for this task. In addiction treatment, missing a high-risk patient is costly, so we also examined the precision recall curve with a baseline prevalence of 0.531, shown by the dashed line. Our boosting models maintained an average precision of 0.822. This shows the model is robust, not just in ranking, but in correctly identifying actual relapse cases. Accuracy isn't enough. We need reliability. We evaluated the Breyer score, which measures the accuracy of the predicted probability. Surprisingly, the complex models such as XGBoost were better calibrated with a score of 0.170 than the simple linear model at 0.213. This means when our model predicts a 70% risk, the real-world probability is indeed very close to 70%. How do we deploy this? A default threshold of 0.5 isn't always optimal. We propose a dynamic thresholding strategy. For screening, we can lower the threshold to 0.47. This ensures we catch over 85% of relapse cases, prioritizing high recall. for resource-intensive intervention. We can reach the threshold to focus on the highest risk to do. We opened the black box using shape analysis. The model identified impulsivity, dis-11, and emotional dysregulation as the top predictors of relapse. Conversely, family support acts as a protective factor. These findings align perfectly with clinical literature, validating that our model is learning meaningful patterns, not noise. To summarize, the performance hierarchy gradient boosting models, such as XGBoost and LikeGBM, are the clear winners, dominating in both discrimination and calibration. Random forest sits in the middle, while the linear baseline lags significantly behind. This confirms our core thesis. Nonlinear modeling is non-negotiable for behavioral risk prediction. We acknowledge limitations. Currently, we use static data collected at ICICT. Future work will focus on two areas. First, incorporating longitudinal data to check changes over time. Second, conducting external validation across different regions to ensure the model generalizes well. In conclusion, we have built a framework that is not only accurate, but also calibrated and interpretable. We believe this approach can serve as a solid foundation for the next generation of intelligent addiction intervention systems. Thank you for your attention.
Hello.
Hello, ma'am. You're audible.
Yes. I want to ask which data set you have considered and how many records that data set is data set have, and also how many features are there, how many columns, and yes, which data set you have used.
So,
I
are you
think
there with us?
okay. I think that might be the.
I think they have some internet issues. I would still like to thank him for his wonderful and intellectual presentation. Moving forward, I'd like to call upon our next presenter, Seguende Brigitte, to present her paper on an ETL method for data warehouse design driven by ontology and LLM. You may present your paper by sharing your screen.
Okay, thank you. Do you see my screen?
Yes, ma'am, we can see your screen.
Okay. Good morning, everybody. My name is Tegawende Brigitte Kentga. Thank you for the opportunity that you give us to present our paper, which title is an ETL method for data warehouse design driven by ontology and large language model LLM. I'm in Burkina Faso at University of Nazi Boni. Our presentation will follow the different steps. After present motivation, we will talk about research objective. Then we talk about state of the art and proposed approach, and finish with case study and conclusion. Motivation, we can say that our work is motivated by the different concepts. First, we have ETL process that require expertise. In fact, decision maker must contact IT expert and express the need of design for data warehouse. We are motivated also by the fact of growing data. Nowadays, with the development of technology, we have many data which are collected into heterogeneous source. This can complicate the process of extraction, transformation, and load data in a data warehouse. We are also motivated that nowadays decision makers want to apply self-service business intelligence. This may mean that decision makers want to build and analyze themselves the data. Now, what is our research objective? Our objective are first, how to assist decision maker in integrating data autonomously. One also allow natural language expression of need to facilitate decision maker. One also automatically generate an ETL metadata. ETL may be a process to extract, transform, and load a lot of data in a data warehouse. A data warehouse, which means a centralized collection, a centralized repository that permits to integrate and store data in order to support the decision maker. And here we want to combine LLM capability with ontology semantic. What is about the state of the art? In the literature, we notice several approaches to make the process of ETL. We have someone who use UML model to draw data in order to extract and load data in a warehouse. We have this one that use ontology to make a Spark SQL script and select data from an ontology which is connected to data source. We have also model-driven architecture approach, graphical flow and ad hoc approach, big data ETL modeling. Here we focus on ontology-driven ETL automation. Because this approach presents several limitations, which can be the heavy manual effort in design ETL, the limited understanding of natural language query, and the weak semantic automation. Decision makers still depend on expert IT. Our methodology proposed is called OLETL. That is a hybrid framework combining ontology and large language model, LLM. This framework based on a local as view integration because we suppose the existence of an ontology built from operational databases of a domain, and a correspondence between the global schema and the local schema is established. So the different entities of the local schema are defined as view on the global schema. This facilitates navigation. This schema represent the global architecture of our approach. The next slide will detail this. Global schema has two main phases: need analysis and data extraction. Need analysis permit to build the query of analysis called global query. The phase of data extraction consists to transform this query in ETL script. What is the role of LLM and ontology? An LLM permit to understanding advanced contextual, extract keyword, and handle complex and ambiguous text. LLM only have a problem and of guidance, domain guidance. So we use ontology for provide domain knowledge representation and supply metadata for source discovery. The first phase that I call need analysis is composed by two steps. The first step of this phase is the identification of key term. User needs are expressed in natural language like sentences. They are then segmented to identify the various key terms, and in this step, we use the LLM to facilitate this. The two step of this phase consists to identify corresponding concepts. Here, we identify the correspondence between the different key terms in the need and the entities in our ontology. In this way, ontology acts as a semantic validator of concepts. This is represented by this schema. The second phase of our approach, intituled data extraction, is composed also by two steps. The first step, identification of data source. The global query that we obtain in the first phase is broken down into a set of subquery using a decomposition algorithm. And for each concept in the query, this algorithm identify the appropriate data source by using the ontology metadata. Now we we build subquery from the result. And the second step, the appropriate data extraction, the subquery are generated and now translating into SQL format. And we can extract data from each search and consolidate them. This second phase is represented by this schema, which were identification of data source in the different database and the data extraction and in each database and the consolidation to have the final result. Case study. Here we take an example of need of analysis, which is who are the people who made statement from Bobo Dioulasso. Here, query segmentation and software removal by LLM give us the concept, people, statement, and Bobo Dioulasso. So our global query or analysis query is composed by the term passenger, because in ontology, the term people is represented by the term passenger. The term statement is represented also by the same term, and the term Bobo Dioulasso also by the same term. So automatic source identification and data extraction give us this query. The first query is select name from passenger, and the second is select number from declaration where origin is Bobo Dioulasso. Now, in conclusion, can say that our approach called OL ETL combines semantic power of ontology with LLM capabilities. These reduce ETL design effort and expert dependency. It also supports self-service BI vision. Several challenges remain, which we will attempt to address in our future work. First, it is extending the framework to take into account the generation of data warehouse schema and testing our approach and compare it with our ETL approach. Thank you for your attention.
Thank you so much. So, ma'am, do you have any questions for her?
Okay. Yes. Can you please go to slide number 11?
11.
Ne 11. Now in this, as the second step is identification of key terms. And then after that, identification of key terms, you are applying, I think, some natural language. Depending on the some natural language requirements and NLM, you are considering, you are identifying the some important key terms. So can you explain how you are identifying that important key terms? On which basis or on which rules or any other criteria, whatever the criteria you have used?
Thank you. But can you repeat your
How
question?
you are finalizing your important key terms out of the key terms that you have identified?
You want to know
How to identify the important ones? Means out of suppose 10 features, 10 keywords, if you are identifying, you are considering only 3. So how?
Yes. Okay. Here, I use an LLM like ChatGPT to facilitate the identification of important key of the sentences. Because
Have
nowadays
you
we
considered
have,
any feature engineering or feature extraction for that?
yes,
Okay, okay. Yes, done from my side. Thank you.
okay, thank you.
Sir, do you have any questions for her?
Yeah, I have a question. Is in your approach, what remains the role of the IT specialist? Because do you see this as replacing technical expertise or refining it toward governance and validation, for example? For the key terms, I suppose the IT specialist should work with an expert, for example. I'm thinking in a cancer, for example. So the IT specialist could identify the key terms in collaboration with the doctors, for example. Or what is your vision about the IT specialist here?
Okay. I don't understand very well your question, please.
Yeah, I mean, for the identification of key terms, depending on the domain, for example, in
Yes,
case of cancer, okay, so
yes.
there are key terms that are different to other domains in health or in other domains. So the IT specialist should collaborate with the doctors, I suppose, to identify these key terms, maybe using LLMs, etc. But do you think this is the role of the IT specialist here in this in your approach?
Here, the ontology represents the domain specialist because the ontology contain all the concept of the domain that the decision maker want to analyze, to make is analyzed. So after obtain the different K by LLM, we are going to match this concept with the domain which is represented by the ontology. So the ontology must validate this K with the real K in the domain. And so we can now generate ETL script to return a result.
Okay, thank
You
you.
understand? Okay, thank you.
Yes.
Thank you so much for that well-presented talk. And last, I would like to call Mr. Carlos Alfredo. Are you there? Mr. Carlos? It seems, unfortunately, he's absent. Then I'd like to proceed by concluding this session. I would like to sincerely thank our authors for their excellent presentations and valuable contributions to this session, and all our participants for being a part of this international conference. I hope this session was informative and enriching for everyone. All the presenters will receive their digital certificates via email within 2 working days. The publication will be live within 7 to 8 months. Kindly cooperate with the ICICT 2026 team. On behalf of the entire team, thank you for your continued support through the 11th edition and the previous editions. We look forward to welcoming you again for the 12th edition in 2027. Now, as a token of appreciation to our session chair, I would like to present these certificates on behalf of Team ICICT 2026 and Global Knowledge Research Foundation and partners. I now invite our session chair, Dr. Suvarna Patil, to present some closing words.
Hello.
Yes,
Good
ma'am.
evening, distinguished presenters, participants, and colleagues. So I would conclude the technical session 13D. I would like to sincerely thank you, all our authors, for their excellent presentations and valuable research contributions. So today's session highlighted innovative advancements in data analysis, AI-driven healthcare models, ontology-based systems, and sustainable ICT practices. So it demonstrates how technology continues to address the real world societal challenges. The quality of discussion and thoughtfulness engagement truly reflects the spirit of this ICICT 2016 conference. So my appreciation also goes to the organizing committee and our moderators for ensuring the smooth conduct of this session. So thank you all for your active participation. So I wish you continued success in your research. Look forward to future collaboration. Thank you.
Thank you so much, ma'am, for those kind words. Next, I would like to call upon Mr. Fernando Latorre to give his closing remarks.
I thank you to all the speakers for your presentations. What we have seen today reflects something important is we are connecting technology with education, health, sustainability, social systems. So we are not just building models, we are building breeds. And I will also thank you, the audience, because the academic exchange is a collective effort, and session like this reminds us why conferences matter. So please continue the conversation beyond this room. That is where collaboration often begins. So thank you very much.
Thank you so much, sir. I extend my sincere gratitude to our session chair for chairing the session with great energy and for their valuable presence and guidance throughout. Now, I would request you all to kindly switch on your cameras for a quick snapshot of the virtual conference for valuable memories to display on our conference website. Everybody, please switch on their cameras. Smile, please. Thank you, everyone. It was such an honor to have all of you here. Stay safe, take care. Bye bye.
Thank you. Take care.
Thank you.